Welcome to this ADF Mobile Insider presentation, where today we're going to be looking at a deep dive into how to use the camera with ADF Mobile. So in context, we're going to be talking about with one of these sort of devices using this little thing here, the camera, to take pictures and actually push the pictures to our ADF Mobile applications. My name's Chris Muir, I'm an ADF Product Manager for the Development Tools part of Oracle Corporation, and it's my pleasure to take you through this content today. So what we will be covering today is obviously talking about the camera in depth with ADF Mobile. But specifically what we will want to cover is not just the camera, but all the different ways that the ADF Mobile can actually access the camera on your device. So that will be through our declarative mechanism, which is through data controls, which support accessing the camera in a drag and drop type fashion. It will also, from a programmatic point of view, be using and talking about, or we'll demonstrate how to use the Java APIs down in your Pojo classes to actually access the camera too, giving you a lot more control into actually what you're doing with the camera and the pictures that are generated. In addition, we'll look at the JavaScript APIs, which you can also use if you choose not to use our AMX pages, but you choose to use our HTML pages within ADF Mobile, and how you can use the JavaScript APIs to take pictures. Finally, given the fact that you are taking lots of pictures and those are actually files that ADF Mobile takes and places on the device, we'll talk about the file management issues that you will hit on the different platforms, that being iOS and Android. Some of the other issues that we need to cover is in terms of testing on the iOS simulator and the Android emulator. Both of them actually handle pictures a little bit differently. In fact, the iOS simulator doesn't handle pictures at all. So we're going to have to look at, well, what you're going to do there, some of the limitations you hit, and just give you a bit of a rounded understanding of developing on the mobile platform and some of the challenges. So before we do a deep dive into using the camera with ADF Mobile, one of the things I need to make you aware of is that this presentation has been done in context of the ADF Mobile version 1 release on JDeveloper 11.1.230. Now in the future there will be other presentations, let me say that again, in the future there will be other releases of ADF Mobile, and obviously some of the features here may change, so make sure that you consult the ADF Mobile developer guidelines, which are available via this bit.ly link to the main ADF Mobile OTN page here. So now let's in depth discuss using the camera on ADF Mobile. Now, in context of ADF Mobile, here is the standard architecture diagram that we'd like to show to everyone. And you'll have in the middle here the JVM, or the device native container, which contains our running ADF Mobile application. And it contains a lot of logic, but one of the pieces of logic it includes is the PhoneGap API, soon to be called Cordova. The PhoneGap API is what gives our ADF Mobile application access to all the device features on the phone, so that being the camera, the GPS, email, SMS, and so on and so forth. So we're very much interested in the PhoneGap solution because it has the true power of how ADF Mobile gets to those services. Now, as I mentioned, we currently use PhoneGap. Now, PhoneGap, through, I guess, a long process of company acquisitions, has been acquired by Adobe, and we in the organisation who did that though has released PhoneGap as an open source project to the Apache Foundation called Cordova. So when we tend to talk about PhoneGap in context of ADF Mobile and Cordova, they're really one and the same thing, though one is the original version that was bought out by Adobe, and the other one, Cordova, is the open source effort that's coming out of Apache. Now, Cordova and PhoneGap are ultimately a bunch of JavaScript APIs that give access to all the device features. So, as it says here in the slide, device properties, SMS, email, contacts, the camera, which we're talking about today, and the photo libraries, and the geolocation and GPS services. Now, in context of ADF Mobile, we do provide you those JavaScript APIs if you want to use them straight from a HTML page running on the device. But in context of ADF Mobile and its Java engine, we also provide a bunch of Java APIs that wrap the JavaScript APIs. They look like Java APIs, you don't understand they're actually working with JavaScript underneath. And it's these Java APIs that you can also make use of. And in context of ADF, we have this concept of declarative programming, so we also introduced this concept of data controls, which are an abstraction that allow you to effectively drag and drop onto a page the controls to access the camera with very little programming. So it's one of the major advantages of ADF as a whole. So in context to all the different devices, services that we allow you to access via ADF Mobile, so that being the camera, the GPS, SMS and email, we do provide different access channels to them. And you can see the 4 access channels here. Again, data controls, EL access, Java and JavaScript. Okay. Now, some of the services are accessible by all of those and some aren't. So you need to understand the combination of where those services are available in ADF and not. So in context of those 4 different mechanisms for actually calling or making use of the device services, let's just go through them in a little bit more detail so you get an understanding. First of all, we'll talk about the data control mechanism. Now, the data control mechanism is available via the data control palette, and you can see a picture of this from the JDeveloper IDE on the right hand side. The data control palette exposes a number of the services for you to effectively, as a programmer, drag and drop and place onto a ADF Mobile AMX page, and JDeveloper will take care of generating all the code and the controls, the UI controls, for actually calling that service. So this takes a lot of the work out, the grunt work of configuring a page. Underneath, JDeveloper and ADF Mobile will take care of at runtime actually calling those device services. So maybe as example from the presentation here, we're talking about the camera. It'll take care of calling the camera services on the device, and you don't have to do any programming. Now, one of the issues that you will hit across different types of devices is that you don't always have the services available. As example, on some Android phones, they don't actually have cameras available on all those different devices. So you may need to, in your page, include logic to say, well, you can't take pictures if no camera is available. So you can do that through what's called the device properties, and we provide EL or expression language access to those device properties to actually determine, well, has it actually got a camera? And at the bottom of this page you can see an example of an EL expression that actually detects if the camera is available. So hash ellipses brackets device scope dot device dot has camera. This will return a true or false value to actually make you determine, hey, is there a camera on this device? And if there is, do we allow the user to actually click the get picture button that you've provided for them to access the actual camera on that device. Moving away from the data controls and the EL expressions, we've also got the Java APIs. Now, the data controls are all good and well for quick drag and drop creation of pages, for instance, to take pictures on your device, but sometimes you're going to need more programmatic control about the actual access of those devices, and this is where the Java APIs come in. Now, we'll definitely have a more in-depth look at those Java APIs in this presentation, but very briefly you can see down below a piece of Java code where we get a handle on a device manager singleton, and through that device manager singleton, on line 2 here we can see that we've simply called the getPicture method, which will ultimately return a URL, or in fact a URI in this case, to a location where the picture's been stored on the device. And there are plenty of different parameters you can use or supply to specify how that picture should be taken, and we'll talk through that in a little bit more detail soon. In addition, if we happen to not be just using Java code, but we happen to be creating HTML code, which has access to the PhoneGap JavaScript APIs, well, literally you can use those same PhoneGap JavaScript APIs to take pictures via the HTML pages that you've constructed. So in the example of code down here, we can see we've got access to a navigator camera object where we're calling getPicture, and we're passing in a bunch of parameters. What to do on success, what to do on failure, and parameters about the quality of the pictures and so on. Again, we'll look at that in a little bit more detail as we go through this presentation. With that in mind, let's now do a deep dive into actually using or making access of the data control for accessing the camera on the device. So let's go into JDeveloper and ADF Mobile and actually construct some pages to do that. So here we have the JDeveloper IDE version 11.1.2.3.0. Now, I've already created a ADF Mobile application workspace on the left called Camera Demo, and in that features you can see that I've already created a feature called Take Picture that is made up of a single AMX page called takepicture.amx. In context of the AMX page, at the moment the source code is virtually empty. On the right hand side you can see it rendering with a header text, but nothing much else. There's no actual controls, real controls to make this page useful. Now, what we're going to use is the data control palette down here to implement the magic of data controls. And the data control palette is one of the really good features of the JDeveloper IDE that allows programmers to very quickly create services in pages, all wired up, all the features there, all the programming done for you, in order to, in the example of what we're talking about today, to make use of the device services available on your mobile and tablet devices. And within context of the device features, you can see a number of different methods available, and these methods you can just simply drag and drop into your page. Now, the get picture method here, and that's what we're talking about today, is if we drop that on the page, we get some options about either creating a parameter form where we'll get a bunch of input text controls where the user at runtime will be able to influence how the pictures are taken. But I'm not going to do that just at the moment because we're going to look at the parameters of taking pictures at a later point in time. So instead, all I want is a button to call the actual camera services, and when we select the actual mobile button option, we actually get this dialog that says, well, let's hard code all those parameters such that the user doesn't have to enter them. Now, I'm just going to enter those values out of memory. Okay, I happen to know what they should be, and we will talk about what those values are, and you should actually set them to at a later point. I just want to show the data control feature at this stage. If I click OK, you can now see we have a command button option, or a component, that calls something called get picture. What's that? Well, if we go behind the scenes to the page, there's a bindings page.def file that actually has an object in it called getPicture. What's that? That's the thing that we're executing to access the picture or the camera on the device. If we click Edit here, we can see we get the same dialog that we saw earlier on where I've hard-coded the parameters. Anyway, returning back to the source code, we can see the command button calls that method and has a textual label of getPicture, and this is what we can see on the right-hand side. Now let's actually look at that running in the iOS simulator and the Android emulator. Now I've cheated, I've already happened to have deployed those to my simulators and emulators. It will take you a bit more time obviously on your device, or your Mac or PC. But here I have the iOS simulator, we have the camera demo application, and you can see the get picture button there. And if I click on it, nothing happens. Why? Because the iOS simulator doesn't integrate with the camera on my Mac. That's unfortunate. Now, however, if you use the Android emulator, which I've already actually deployed our application to, and I'll just start the application now. Up pops our page, you can see the get picture button, and now this time let's click on it. And you can see from the context of the Android emulator, it does actually use the camera on my Mac. I guess I've got to tilt my head this way to be the right way up. Now that we've covered looking at how to access the camera from the data controls, very much in a drag and drop way to create your pages. Let's now look at how to access the picture or the cameras from Java code. Okay, and this will provide you more sophisticated access to control the cameras, because you can do things like check if the camera is available, check the results, manipulate the results, and the data control way is a great way to create pages very quickly, but doesn't necessarily allow you to have the full sort of control or access to the camera that you would want for a real application. So returning to the JDeveloper IDE, we still have the same camera demo application open on the left-hand side, and in the features, I've pre-created a new feature called Take Picture via Java. Now that feature just has a single AMX page. You can see it here, there's no code in it at the moment, and rather than using the data controls to take pictures, what I'm going to do is actually create my own button with the label or textual label get picture, and we're going to wire up a Pojo or a Java class behind the scenes in order to take the picture for us. Now I've got the command button here. Here's its property inspector, and to create the Pojo or the managed bean behind the scenes, and actually to activate that, I can click on the edit for the action. I can create a new managed bean called take picture of view scope, and a method which is do take picture. And you might have noticed on the left hand side a Java class has been created for us, and you can see the do take picture method. And if we go down and look at this ADF Mobile config file, which is the task flow for these actual AMX pages, if we open that up, we go to the overview node, you'll notice that the manage bean has been configured for us, and that's what we were configuring in the dialog, but the entry is here. The actual settings have been put in this file. So what we have here is the actual device manager class, that being Oracle ADF Model Data Controls Device Manager, that you import into your Java classes to access all the underlying features of the device. So this is the Java API for instance, taking pictures. And down below you can see on lines 17, 18 and 19 the actual getPicture method, which takes a bunch of parameters and returns a string. Now what I'd like to talk about here is those individual parameters, what they do and what the string result actually gives you. So the quality parameter, ultimately an integer of value 0 to 100, is the quality of the image that's taken by the camera. Now you put this very high, you get a very high quality image, but you end up taking up more storage on the device. Put it very low, the picture isn't particularly good, but you're not taking up all the storage on that particular device, which may be an issue for devices that only have a small amount of storage. The destination type parameter, which takes two values, either 0 or 1, and there are constants in the device manager package that you can use to refer to rather than supplying those values. But the two values here, 0 or 1, mean that the string that the getPicture method returns either returns a base 64 encoded string of the image, which is particularly useful if you want to then stream the image out via a web service call, pushing it back to a server. Or, if you give it the value 1, it will return a URI of the format file where the actual picture is located on the device. Now that's particularly useful later on if you want to invoke say an email and attach the file to that email. You need to know where that file or the picture as such is located on the device, and that's what that option gives to you. The source type parameter that takes either 0, 1 or 2 as a value allows you, in context of the picture, to either access the library on the device, the album on the device, or take a picture itself. Now this is a little bit different on each platform, because on iOS you actually have a library and an album, whereas if I remember correctly on Android you only have a library. So the options here really do depend on the device that you're using. However, if you don't want to get the image, a pre-stored image from the library or album on either device, then you would call the camera option 1, and that will allow you to take a picture, which then again can either be returned as a base 64 encoded string, or you get a URI to its location on the device. Allow edit. On some devices, again it depends on iOS and Android, when you take a picture, the user is allowed to edit that picture before it's actually stored and returned. So this might be things like cropping it, changing the color tones and so on. So you can influence that by a true or false Boolean value, whether the user actually has that ability. In terms of the encoding type parameter, another integer, 0, 1, does the image return a JPEG or a PNG image? In terms of the encoding type, another integer with a value of 0, 1, does it return, the camera that is, a JPEG or a PNG image? JPEG is better for photos, PNG is better for computer generated images. Target width and height is, as you can guess, is once you've taken the picture, shall it scale to a certain pixel height and width? And finally, the return parameter here, which returns a string. As we said earlier on, that's influenced by the destination type parameter. Are we returning a base 64 encoded image, or are we just returning a file URI to the specific image that's stored on the device? So in the previous slide we alluded to there are some differences between taking pictures on Android and iOS, and you'll need to take this into consideration when developing your applications. This is one of the issues that we get when you're trying to write applications for multiple devices. For Android, the getPicture method, well, the allow edit parameter is ignored because it doesn't give the user that facility currently. There isn't a separate album or library or photo role, that's all the one and the same, so the source type parameters open the same thing, and the camera encoding parameter is ignored. On iOS, for a call to getPicture, well, one of the things you need to keep in mind is the quality. If you set it above 50, you may consume all the memory on the iOS device. In terms of the destination type parameter, unlike Android, which saves images into the actual photo album, in iOS, the pictures are actually saved to the application, and it's very hard to share them actually between applications. This brings up an interesting issue with the iOS applications when using getPicture is if you upgrade the application or you delete it, the pictures or the files are automatically deleted as they are part of the application. So there's slight nuances and differences between the two platforms that you need to keep in mind. Now that we've seen the Device Manager API and the getPicture method and the Java doc, let's actually have a look at a real Pojo implementation. So in this particular example, we have a method called ActionGetPicture on line 4 configured in the myBean, and this would be the managed bean that I showed you how to configure earlier on. And the very first thing we need to do before taking a picture in the Java Pojo class that we've created here is I need to get a handle on the Device Manager object, effectively a singleton returned by Device Manager factory getDeviceManager. Once we have access to that, we can then call, in this example, the getPicture method, where the very first parameter is the quality of the picture we're going to take. On line 9, we can see that then the type of output that we want from this particular getPicture call, well, we've got two choices. We can either get base64 encoded or file URL, and those values would be 0 or 1. Now, the APIs for Device Manager actually provide a bunch of constants that you can use here rather than specifying the integers 0 and 1. So in this example, we're using camera destination type file URL. The result of that is, to this particular method, getPicture, it will return a string not of a base64 encoded version of the image, but rather it will return a URL or URI path to the image on the device, or the format file : // the path and then the actual file name. And that file name is typically generated by the device when the picture is taken. Talking about the picture being taken, in this example we're not actually taking a picture, we're grabbing the picture from the pre-existing photo libraries on the device, and that's quite a valid thing that users will do, because often they won't have time to go into your application. They will just go straight into the device, take a picture, and then later on want to attach that picture to your application. So that's why we need these options here. The false parameter here stops the user from editing the picture before it's actually given to our application. The encoding type here is, hey, we want the image as a JPEG. Finally, the last two options here, which are 0 and 0 piece, is actually the ability to scale the image after the fact. Now, because I've given it the value 0 and 0 here for height and width, it will not do any scaling whatsoever. But if I change that to any values, it'll actually attempt to scale it to that pixel height and width. Now, what I've shown you there is a very rudimentary Pojo example, but in reality, once we're coding at the Java level, there's all sorts of fun things we can do. For example, one of the first things you might want to do is, before allowing the user to take a picture, is actually call the Device Manager hasCamera method to check, hey, does the device actually have a camera? At that point, trying to take a picture if it's not there. In addition, we should do our typical defensive programming, and we should attempt to capture any exceptions that are raised. And the mobile framework actually has an exception class called ADF exception, stored in Oracle ADF MF framework exception, that you can attempt to capture to see and handle any particular ADF mobile exceptions that are raised. Now that we've looked at accessing the camera via the data controls, basically dropping a data control onto the page of an AMX page, and also accessing the camera via a Java API from a managed bean of an AMX page, let's look at the third option available to us for cameras. Now, that third option is actually not going to use an AMX page at all. ADF Mobile supports not just rendering AMX pages, but also supports rendering local HTML pages rendered on the device, and you can make calls out to the JavaScript APIs that are available to you in this example to access the actual camera. So let's have a look at that in a little bit more detail. So returning to JDeveloper 11.1.2.3.0, I've already in this example application created a new feature called Take Picture via JavaScript API, and in addition, rather than having the content set as AMX, in this case I've set it's a local HTML page, and I've generated a local HTML page called Take Picture via JavaScript. Okay, here is that actual file, and you can see that it is just a standard JavaScript. Let me say it again, it is a standard HTML page, which we can do any HTML programming, we can call any JavaScript APIs we want. Now, in context to the JavaScript APIs that we're going to make use of here, ADF Mobile actually has embedded into it the Cordova or PhoneGap 1.0.0 APIs, the JavaScript APIs for taking pictures. So you're not actually going to be using an ADF Mobile solution, you're going to be using the Cordova or the PhoneGap solution that is actually embedded in ADF Mobile to take pictures. Just a little reminder that this presentation was done with ADF Mobile 1.0 and it was the 1.000 PhoneGap version that we were using. Now in future versions we may upgrade to other Cordova or PhoneGap versions, so you need to check out the relevant documentation such that to make sure that the documentation or the examples I'm giving here I should say are correct. But you'll get the general idea of what you're attempting to do. It's worthwhile looking at the Cordova documentation pages, because if you drill down you'll actually see the code that we're literally going to call in the presentation here. Now I'm going to give you some examples, but they have some really good examples on their websites, and they also have some really good descriptions of what can go wrong on the different platforms for accessing the different device features. So what we have an example of here is a HTML page with JavaScript in it, which is going to allow us to call the PhoneGap libraries to take a picture. Now the very first thing we need to do is import the PhoneGap JavaScript library, and that's actually included with the ADF Mobile, and you can see the version 1.0.0 moniker here. You'll also notice the path of the PhoneGap library. Now, depending on where you created the page on the ADF Mobile application, that path will be different for you. Now, I'm not going to go into the nuances of that in this particular presentation, but to say go and read the ADF Mobile guide here to work out what that should be. Further to that, in our example, we then see that within the HTML body, we have a method called takePicture, which is called via a button, okay, on click. Now, that particular method, takePicture, is defined in our JavaScript tags above, and you can see that function takePicture makes a call to an object called navigator.camera.getPicture, and the navigator object is, and the camera object is something that PhoneGap provides. Obviously, the getPicture method here, it kind of looks very similar to the Java APIs. And remember, ultimately, the Java APIs that Oracle is providing in ADF Mobile behind the scenes is calling down to the PhoneGap libraries. So a lot of the parameters you see here will be exactly the same as you saw over in the Java APIs that we saw earlier on. And this gives you a little clue when you're reading the Oracle documentation. If you can't necessarily find an example that you're interested in, go to the PhoneGap or the Cordova documentation to get more information, because ultimately we're just a layer sitting on top of those services, and you can find from their documentation all sorts of interesting issues and implementation details that we will just refer you to ultimately. What's a little different about the JavaScript API from the Java API is not only does it take a document of different parameters, so you can see the quality parameter there, the destination type parameter, and so on and so forth, is it also takes as the first two parameters an onSuccess parameter, which if the picture is successful, that's where you code how to handle what to do with the picture that you've just taken, or an onFailure function, which is where you write your code if the picture doesn't get taken successfully, how you're going to handle that. So the APIs, because of the way JavaScript works, are a little different in terms of the mechanics, but ultimately the getPicture method, the parameters that it takes beyond onSuccess and onFail are just the same parameters that we saw in the Java API. And also, to remind you again, because this is a very strong hint here, you can go to the Cordova or PhoneGap documentation to find out all the details about those particular parameters and all the nuances of using those on different devices. Now that we've gone through all the different ways to actually access the camera on the device via the data controls, the Java APIs and the JavaScript APIs, let's just round off this discussion with some discussion about file management and some of the limitations that you may hit. So when you take a picture with the different devices, where the file is actually stored is actually different on different platforms. So we can see here in this particular slide for iOS and Android. On iOS, the files or the pictures get stored in localhost file mobile applications, and on Android it goes into a location MNT, which is mount, SD card, DCIM and camera. The actual path and file name after that is again platform specific, and if you look at the iOS example, right near the bottom, you can see that when it stores it in localhost var mobile applications, it then generates some sort of unique ID as another directory, temp, and then photo 001, 002, 003.jpg, and so forward. Whereas with Android, you'll notice that it doesn't bother to store it in an applications directory. It actually just stores it under the general camera directory, but it gives each JPEG a unique file name as such. Why it's useful to know about these URIs is when you take a picture, is ultimately if you decide to return a file URI, it's one of these paths that you will get, and you may use one of these paths as an example to attach the picture to an email that the application sends out later on. So understanding the format on the different devices is useful. Once we have a bit of an understanding of the different file paths, it's then useful to understand the different file systems on the different platforms. Now with Android, when you take a picture, it stores it to the album, and the album, okay, is accessible by all applications and the user, of course, and they can see all the pictures they've taken, even though it was taken by your specific application. And in a way, this reflects the open nature of Android, and is one of the main advantages of Android over iOS. Now iOS, it's a little bit different because the application pictures are actually stored in a directory of that actual application. And I guess this reflects the iOS's more closed nature, and which Apple is quite famous for. Now with that in mind, we're seeing changes by both vendors in those solutions. Android's openness is actually an Achilles heel for security, where iOS, the closed nature, well, that's causing usability issues on the device. So both vendors are likely to change some of their solutions here, and you need to be cognizant of that. Now, I'm not an Apple programmer at all, but I see little hints beyond iOS version 6 that Oracle's slowly changing the way that images and other files are stored on those devices to allow images and other files to be shared between applications. So beyond Oracle's ADF Mobile solution here, you need to do a little bit of investigation of the different platforms to see what the different vendors are doing with their solutions. It's well worth noting that when the files are stored either to the album on Android or the specific directories on iOS of the application, that the files are not encrypted or secured. You can get, for both platforms, tools that will sniff the directories of those devices, and you can access pictures, other files, and look at them without necessarily having to go through your applications. So be careful about storing sensitive information on the device, and if you do, maybe you want to think about encrypting it. Now for pictures, that's unlikely, but we're talking more generically about the file system here, so just keep this in mind. Finally, let's cover off some limitations of taking pictures. One of the really good things, again, about the PhoneGap and Cordova documentation is that it has awesome comments on what is allowable and not possible, or the different quirks of the different platforms for all the different methods that you might make use of. So while it's the description of the JavaScript APIs, again, remember that the Java POJOs that we're creating really ultimately sit on top of the same code there, and the same documentation really applies. So you can see some excellent little hints in here, essentially about what facilities are available on Android, what facilities are available on iPhone, and PhoneGap and Cordova continue to improve upon this documentation, so go and read it. There's lots of different things that you need to learn about the different platforms. As we also saw earlier on in the presentation, that when we're testing the particular camera features on the iOS simulator, we have no ability to actually take pictures within the iOS simulator. So if you're going to test for iOS, you really need to deploy it to the device and take pictures with the device to make sure that your code's working. Now the Android emulator does have the ability to use the camera on the development PC or the Mac that you're using, which is great, but if you do any reading about mobile development beyond Oracle solutions here, the one thing that mobile developers tell you is don't rely on just testing in the simulators and the emulators. Get a real device and test on those, because there are all sorts of quirks that the emulators and simulators don't necessarily reflect or replicate from the real devices. So you have been warned. So let's conclude this deep dive into using the camera via ADF Mobile. Now, one thing I want to highlight up early again is remember underneath in accessing the device features via ADF Mobile, ultimately we're using PhoneGap or Cordova. Okay, it doesn't matter if you're accessing them via the data control or you're accessing them via the Java APIs or ultimately accessing them via the JavaScript PhoneGap APIs themselves. It is PhoneGap that you're using, or Cordova. So while our documentation will show you how to do that, it's the PhoneGap and Cordova documentation which is an excellent reference because it gives you all sorts of information beyond just the parameters, but all the different device quirks. Keep that in mind, it's a really good resource. The next thing to remember when accessing the features on the device via ADF Mobile, that we provide different mechanisms for doing that. The declarative data control way, the expression language access way, either via Java code APIs or JavaScript APIs. And it all depends on, well, if you want to do it in a declarative fashion, you use data controls, but if you want more programmatic control and sophisticated control, you use maybe the Java code APIs. And if you're not using AMX pages, but you're actually creating local HTML, then you'd use the JavaScript APIs. Ultimately, remember, in addition, that you shouldn't just test via the simulators and emulators provided by iOS and Android. And we did see some limitations between the different simulator and emulators here. It's really important with all your ADF mobile development that you also do a strong set of testing on the actual devices themselves. Now, this is not exactly true of iOS because there's not a large amount of devices you need to test on, but very, very true of Android and all the different Android devices that are available via all the different telecom companies. There are lots of different devices available on Android with all their own little quirks. And if you want to support customers that have those different devices, you need to deploy and test on those specific devices. Welcome to the world of mobile development. It's not an easy environment to work with, but the opportunities are quite large. If you want to learn more about accessing the device features through ADF Mobile, refer to the ADF Mobile Developer Guide 11.1230 at the moment. That's section 9.5 in the current guide, and there's a bit.ly link there that'll take you straight to it. Remembering that this presentation might be slightly out of date by the time you actually use it. There might be a new, review this, there might be a new ADF Mobile version out. So always check that you've gone to the latest documentation from Oracle. Again, remember that in addition, there's the PhoneGap and Cordova documentation, and for the specific version of ADF Mobile version 1, it is using PhoneGap 1.0, and there's a bit.ly link to take you straight to that. And finally, this particular recording, which has all been about the camera, accessing the camera via ADF Mobile, there will be another set of ADF Mobile Insider recordings, which will look at accessing the other device features, such as the GPS, email, SMS, and so on. So keep a lookout for those on the OTN website. If you're interested in learning more about ADF Mobile, head to the Oracle Technology Network, OTN. There's a bit.ly link there that will take you straight to the ADF Mobile page. Of course, Oracle's always expanding all its documentation and collateral for you to use, and there are a number of downloadable demos, tutorials, there's the discussion forums, sample applications, and most importantly, the ADF Mobile Developer Guide. Thanks very much for your time today. I hope this presentation has been useful. If you have any feedback, please send it to the OTN JDeveloper forum, and keep an eye out for the additional ADF Mobile Insider presentations on the other device features soon.